So the next section is group data mean, and essentially this whole section's come down to just two questions. It's just when it comes to it, it's just different way to find the mean. And the two most important ones we're going to talk about is mean of a frequency distribution and the weighted mean. Okay, let me give you a scenario. So let's suppose you did a frequency distribution, you know all the portions, we can do that now, right? Given all the raw data, and you go to your boss and you give him this, and you give him a frequency distribution. So he's happy when it comes to it. However, he also asked, what if, I want to also find the mean of the data set? And you kind of made a mistake. You actually, deleted all the data values themselves. So the question now becomes, how do you find the mean of just this, right? Because notice, remember, right, 2 only means you only have 2 data values within there, right? 10 means you have 10 data values within here, but you don't know the exact numbers. So you can't just, add up all the numbers and divide by how many you have because, well, what are the numbers themselves, right? So we have that dilemma. So when it comes to finding the mean of a frequency distribution, it's going to be a little different. And how that is different goes based on this first equation. So this is what we have to do when it comes to finding the mean of a frequency distribution. Okay, so a mean is going to equal the sum of f times x. So order operations, you first multiply and then add, divided by the sum of f. Now f represents the frequency of each class, so it's going to be these numbers here. Now this one you got to be very careful of. X is actually the midpoints of the classes. And we talked about midpoints a while back in chapter 2, right? The frequency for classes, how to find the midpoints? You add them and divide by 2, right? And you want the midpoint of each individual class. So what this is saying is, first you're going to do is you're going to multiply the frequency times its midpoint. Okay, so that's order operations, right? Then you're going to add all those numbers up, and that's going to be a top number. And you're going to divide by the sum of all the frequencies, right? Because that means sum. So you can literally just add up all the frequencies together. Okay. So here's a little example we're going to go through together when it comes to it. Okay. So here's our example. So here's our time and money, it's a frequency, and right, we want to find the mean of it. So first we want to do is find the midpoints, right? Because we need the midpoints. So we add them, divide by 2, and here are our respective midpoints for the classes, right? For each one. Okay. Now, according to my equation, right, order operations, we first multiply f times x. So that's exactly what we're going to do. We're going to multiply f times x. So literally, you could just multiply straight across. 2 times this, 10 times that, 3 times that, 1 times that, 2 times that. And then we get these numbers here. Right, so literally just multiply across. Now, next thing it says is to take the sum. So the way we're going to do is add up all these numbers. And that number is going to be the very top one we need. So we need basically 2 numbers. The very top one, which is going to be this one, and at the bottom is the sum of the frequencies. So we're just going to add up all the frequencies together. We get 17. So now look at the mean. You literally divide this number over that number. And we get roughly 226.06. And that's how we're going to find the mean of a frequency distribution when it comes to it. Because again, right, given a frequency distribution, you do not actually have the data values. So this is a good rough estimation of what it would actually be if you had the data values themselves. Okay. Right. So before we go on any further when it comes to this, what I want to do is just, if you have a back page, right, it says question 1 and question 2. So here's going to be a question 1. So now we went through the example, right? Our question 1 is going to be this. We want to find the mean of this frequency distribution. That way you have it, here's an example, and we now do another example, right, from first start. Okay. So we want to find the mean of this frequency distribution. So let's just write our equation we're going to be using. Right, that is our equation. And we're going to mimic exactly what this equation did here, right? Because we're just finding the same thing, finding the mean of this new frequency distribution. So just a quick reminder, right? So the first thing we have to do is find the midpoints, no matter what. So I'm just going to extend this out and just find midpoints now. Okay, so midpoints, right? We add them and divide by 2. So 60 plus 69 divided by 2 gives you 64.5. And then we do the same thing for the rest of them, right? Just add them and divide by 2. So I'll just quickly write those down. now we have those. Well, what's the next step? Well, the next step we did for an example is we want to multiply f times x. So that's what we did here, right? We literally multiply straight across. So we're going to do the same thing. We're literally just multiply straight across. So now we have a new column of f times x. So if we just multiply straight across, so we're going to have 3 times 64.5 is 193.5, and I'll just keep going. Right, 12 times 74.5. Keep going. 15 times it. 8 times it. And then finally 1 times it, which is itself. Okay. All right, so now at this point, right, we have this done. Now we go to equation. Well, remember, what we now want is we want to take the sum of all of these. So we're literally going to add all of these numbers up, and that's going to be only the top number we're looking for, right? So if we add all of these up now, so 193.5 plus 894 and so forth, and see what we get. It gives us a grand total of, so the sum of f times x is equal to 3215.5-ish. Hopefully that's what you guys got as well. Okay. All right, so that's that portion. Now the last thing is we want to find the sum of all the frequencies of the f's. Okay, so when we do that is we just add them all up. So we're going to add up all the frequencies together. So 3 plus 12 plus 15 plus 8 plus 1 gives us a grand total of, I believe, 39 if I did my math correctly. And then finally what we want to do is divide these two numbers. So our grand total, so the mean itself for this frequency distribution is going to be 3215.5 divided by 39, which gives you approximately 82.45. Okay. So if this was our, let's say, for example, a frequency distribution of the mean of the grades, let's say, of this class, the average grade in this class would be about a B, right? 82%, which is really good when it comes to it. Okay, so that's how we find the mean of a frequency distribution when it comes to it. All right, so that's the first type of mean we're going to talk about. The second type of mean we're going to talk about is something called the weighted mean. Okay, and that's the next example we have underneath this one. So we go back a page itself. Right, so it's down here. Okay, so the weighted mean, the most popular examples when it comes to weighted mean is finding GPA and also finding your overall grade. Those are the most popular ones when it comes to using the weighted mean, as I illustrated here, right? So the most popular ones is finding your GPA and calculating your grade. Those are the most important ones. And probably one of the other ones is pretty much used when it comes to it. So, you know, every professor calculates your grade pretty much this way as well. And then your whole school calculates your GPA exactly how we're going to do it now. Okay. So again, because it's a little different, that means our equation is going to be a little different as well. Okay. So our equation, when it comes to how to find the weighted mean, very similar to the one we just did, except for W's. Right? Notice. Instead of W's, now we have F's up here. So what this says is, so now in this case, X is the data values. We'll talk about it a little bit. And then W is the weight of each data value. Okay, when it comes to this, so the weight of each data value. All right. So let's do an example like we did before. How do we use the weighted mean? So here's an example here. So a student is enrolled in 4 classes: math, Spanish, English, and anthropology. The student wants to know what her GPA was for the semester. The credits for the classes: math 4 units, Spanish 3 units, English 4 units, and anthropology 5 units. The grades are as follows. So here are grades. That's what they got. Not so good with a D, right? And just do the units. So basically, this is a summary of what they gave us here, right, when it comes to it. Okay. All right. It also says at the very bottom, each letter grade is given a numerical value. So A is 4 points, B is 3, and so forth down the line. Okay. So basically, this whole thing is the question. You guys are wondering, that's a lot of questions right when it comes to it. Next up is the actual, work by, but that's the whole question itself. Okay, so the whole concept of the weighted mean is you want to find two things: which are the data values and what is the weight? So what's changing? Okay, so first of all, credits, right? So everybody hopefully understand, not every class has the same number of credits or units respectively, right? So some classes have 5 units, 4 units, 2 units, or even 1 units, right? When it comes to it. So think about that, right? So this is what's here, and the grades themselves are assigned a single value, right? So every A is given 4 points, no matter how many units it is, right? Every B is given 3 points, again, no matter how many units it is. So I have a question for you guys. What do you think is going to be the weight? So the weight is what's changing from data value to data value, right? So key thing, right? Let's look at these two A's here. They're both going to get 4 points, right? Because it's A. However, do they both have the same weight or same number of units? Hopefully you say no, right? They have different units. So what's changing? The points of the grades or the units? Or the credits, it says. Hopefully say the credits is changing, right? So therefore, this is going to be our W, and this is going to be our X's. Okay? So I know it's a little tricky when it comes to it, but I'm going to give you guys a little hint. When it comes to the weighted mean, the weight is always the credits / units, depending on if you call it units, and the percentage of grade. And we'll talk about that in the next example, why that's important, the percentage of the grade. Okay. Again, we'll talk about why that's so important. Okay. All right. So now that we know, give you guys that hint, right? So in our case, the weight is the credits in units, like we said earlier. So this is our W's. And now the next page, I just break it down, right? So what we do now, this is going to be our X's because this is the grades, and this is our W because that's our units. So I've got it kind of cut off on my end when I come to it, but hopefully you guys can see it on yours, right? So in this way, the credits are the credits are the weights, and the grades are the X values, right? That's what I have here. So now that we have that, we can now create our mean.